Hi, so this is our second video on integrating with vectors. So in example 2, we're told that a particle is moving in a plane such that at time t seconds its acceleration is given as this vector, and when t equals 2, the velocity of m is 12I minus 2j meters per second, and the position vector of m is 10I plus 15j meters with respect to a fixed origin. In part A, we've been asked to work out the angle between the motion of m and the I component when t equals 3, and then for part B, to find the distance of m from O when t equals 1. Okay, so for part A, to work out the angle of motion of m and the I component when t equals 3, we need to work out velocity, because velocity has direction. So the velocity will be the integral of the acceleration with respect to time. So if we substitute this expression for acceleration, v will be the integral of, we'll use column vector form, 12t squared for our I component and 6t for the j component. Put this in brackets and we'll integrate with respect to time. So the velocity, if we integrate the 12t squared, we'll add 1 to this power and then divide by the new power. So we'll get 12t cubed over 3, which will give us 4t cubed. And we'll integrate the j component, we'll have a 6t squared over 2, which will give us 3t squared. And then we'll close this bracket. But we also need to add the constant, which is also a vector. And then we can work out this constant because we're told here that when t equals 2, the velocity is 12I minus 2j. So we can substitute each of these into our expression for velocity. So our velocity of 12 and minus 2 will equal 4t cubed when t equals 2. So that'd be 4 times 2 cubed, 8. So that'd be 32. And then 2 squared is 4, times that by 3 and we get 12. Plus the constant. So if we move this 32, 12 to the left-hand side, we know the constant will be 12 minus 32, so negative 20, and negative 2 minus the 12, so negative 14. So now we can put our constant back into our expression for velocity. So v will be 4t cubed minus 20 for our I component, and 3t squared minus 14 for our j component, and this is in meters per second. Okay? For part B, find the distance of m from O when t equals 1. So now we need to work out the displacement vector. So now we need to work out r, and this is equal to the integral of velocity with respect to time. So r will be equal to the integral of our expression for velocity. So 4t cubed minus 20 and 3t squared minus 14. Again, integrated with respect to t. So if we integrate our I component, r will be 4t to the 4 over 4, so t to the 4, minus 20t. And for the j component, 3t cubed over 3, so t cubed minus 14t. And again, we need to add on our constant. And we're told that when t equals 2, the position vector of n is 10 and 15. So we'll substitute 10 and 15 in for r. And when t equals 2, we get 2 to the 4, which is 16, minus the 14, so negative 24. And then 2 cubed minus 14 times 2, which gives us negative 20, plus the constant. So C then, as a vector, we'll move a negative 24 to the left-hand side, so we get 34, For the j component, we'll move a negative 20 to the left-hand side and we'll get 35. So r, in terms of t, will be t to the 4 minus 20t plus the constant 34. And then for the j component, t cubed minus 14t plus 35. And this will be in meters. Then for part B, find the distance when t equals 1. So if we substitute t equals 1 into our expression for r will be t to the 4, so 1, minus 20 times 1, plus 34. The j component will have 1 minus 14 plus 35. So our displacement, working out our I and j components, will be 15 in the I direction and 22 in the j direction. But because it wants distance and not displacement, we need to find the magnitude of this vector. So we'll take the square root of 15 squared plus 22 squared, and we'll get a distance of approximately 26.62 meters. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.